Trusses are used to support roof, strengthen bridges, or support towers. The basic question: why should we analyze a truss? This is because if you want to design truss members and its joints properly, you should have clear knowledge of what is the load carried by each member of the truss under any given loading condition. Before going to truss analysis, let's see the main assumptions behind it. Truss members are connected at their ends only, and they're connected by frictionless pins, so you don't have to consider any secondary bending moment, induced due to force friction. Next assumption is that truss is loaded only at joints, and the last one is weight of truss members can be neglected compared to load acting on the truss. Force developed in a truss member is always axial. It can be either tensile or compressive. If a member is under tensile load, this will be the direction of internal force developed. So you can notice that, under tensile load, internal force developed in the member is directed away from the joint. Similarly, in case of compressive force, the internal force developed in the member is directed towards the joint. The most common way to determine forces inside a truss is method of joints. The basic concept of method of joints is that, since the truss is in equilibrium, each joint in truss will also be in equilibrium. The procedure for method of joints is as follows. First step, determination of reaction forces. For this purpose, we can use three equilibrium equations of truss. That is, sum of horizontal forces 0, sum of vertical forces 0, and moment acting at any point in truss is 0. After determining the reaction forces, next step is to apply concept of equilibrium of joints. Consider a joint where there are not more than two members in which forces are unknown, two unknowns because we have only got two equations of equilibrium to solve them. Joint is in equilibrium in x direction and joint is in equilibrium in y direction, so we can solve for both the unknown forces. Please note that we cannot use equilibrium of moment at a joint because moment produced by member forces in a joint is 0, since all forces are passing through the same point. Once you're done with one joint, you can move to the next joint and do the same analysis there. The procedure is repeated till we have solved all the unknown forces in truss. Now let's do a sample problem. Stress analysis of following structure, which is used to lift weight. One end of that is connected to a roller and other end to a pin. So first step, determination of reaction forces from free body diagram. Since one end is connected by a roller, reaction force will be purely vertical. At the other end, both vertical and horizontal reaction forces are present. As the whole structure is under static equilibrium, we can use three equilibrium equations to solve for three components of reaction. Now analysis at each joint. Let's assume that all members are under tension, so forces are moving away from joint. Internal forces developed, and number of unknown forces around each joint is, as shown here. It's clear that we could start our analysis either from joint A or from joint D. Both are having two unknowns. Other joints are having three unknown forces. Let's start with joint A. Forces in both members can be solved using the equilibrium formula. If sign of any force comes negative, that means that member is under compression. Now we can move to point B. Their number of unknowns are 2 now. Using the same concept, we can solve for forces in members 3 and 5. Now the only unknown force remaining is in member 4, which can be easily solved by considering equilibrium at point C or point D just by considering one equilibrium equation. Hope you have a good understanding on structural analysis using method of joints. Thank you.